best. And it's kind of that thing about keeping in the herd. And soft drinks are the same, particularly bound soft drinks. But the bound soft drinks are bad because effectively there are kernel threads which can then get pinned, and they're on a particular CPU, and they can be pinned, and the network package will just have to wait for something else to finish. So bound soft drinks are a bad thing. It's basically it's there for NICs that don't have hardware support for packet classification, and so you can use it for that. But there has been performance advice for particular situations to say, oh, bound soft drinks, good idea. But actually, in most situations, it's bad for latency, it's bad for throughput.
If you had to get up, sorry, I think you're going to answer the question. I was going to ask a question which I think you're about to answer.
Oh,
I'm going to ask where your first guess would be for NFS issues, server, client, or network.
Yeah, one of them. Hey, this is the open mind. Yeah, it's somewhere in there. It's observe. Yeah, it'll definitely be one of those. Yeah, no, I'm not being flippant, but I wouldn't even have a guess. I think you've got to start from the client, though. So you start looking at the client, but that doesn't mean it's the client. It's just that's the point. And sometimes you kind of have to make a stab and say, well, I'm going to assume, but I still might have an open mind. But I'm going to assume it's the client. And then I'm going to, okay, let's go and either rule that in or rule that out. And you would learn stuff while doing that and then move on. But I would start with the client. Does that answer your question? No. Yeah. I wouldn't assume. Yeah. I would blame the network, actually. In the same way that I used to blame VXFS. And most of the time it was right. Or that you blame large storage arrays when IOStat says the high latency. You're right most of the time. But that's wrong. So for NFS on the client side, most of the time, if you've got random access and small blocks, 8K or whatever, less, hands off, default is normally good. Unless you've got seriously large machines and serious numbers of connections. When you've got sequential access, large reads and or writes, it's worth setting the read size and write size buffers and the mount options. And NFS B size, etc. system, and the read ahead. But you need to kind of do the sum so that it's not too large. And your workload has to benefit from read ahead. And again, as if you read ahead too much, and you can overrun part, and there is a bottleneck somewhere in your system, you can actually make things worse. So it's worth doing the sums. The thing is, for R size and W size, you can set these on the fly, your MDB, but they don't take effect until a file system is unmounted and remounted. So don't think setting them with MDB, oh, there's no difference. You've actually got to remount file systems. And jumbo frames, good thing. Well, as I said, packet drops are very bad. Less than 1% can kill a busy link. And this seems to be something that is kind of exacerbated by 10 gig. And pay serious attention to the network configuration. I found that apparently network backup solutions do not generate any network traffic. This surprised me because you say, oh, right, okay, you've got this really bad performance at this time, and they wouldn't tell you that there was a backup running, or it wasn't obvious. And I think, well, I could conclude they don't generate any network traffic because it wasn't worth them telling me about it. But a large proportion of network performance issues are because backups are running at the same time. Maybe I'd go for that one first, actually, which is not network. So anyway, NFS server. How many people know about delegations in NFS v4?
I was going to say, NFS v4, wouldn't you say that's one of the herd arguments? Because most people are using NFS v3 still.
No, I'm not sure that's true, because most people will just go with the default, which is 4.
Not the ones I meet.
No, most people will go with the default, which is 4. See, relatively few issues in in terms of functional issues. There were some issues around delegations 2 or 3 years ago. Those seem to be fixed. But delegations can create some issues if you have multiple clients accessing the same file. So the way delegations work is to say, okay, on the server, I'll give a file to Chris. So here, Chris has a file, and he has I've delegated it. So he will update it, and then, let's say Phil wants that file. Phil as an NFS client will ask me, and I'll say, oh, I better record my delegation, and that might take up to 30 seconds because he's a slacker. So I will get it back, and then I will give the delegation to Phil. Or I might not decide to I might just not give a delegation out. There is some logic in there that says, actually, I'm not going to, not really trying to access, I won't bother. But this has great benefit for performance, because when Chris has the file and the delegation on that file, he can read and write it, and when he closes, he can give it back to me. So there can be great performance gains because he's not having to go over the wire except on the close. But you can look at del purge and del return in netstat to see if delegations are firing. There's also a bunch of MDB commands that you can see if you do ::d commands in MDB and pipe it to grep NFS. So it will show you that. But on the NFS server, the main things I tend to see are the sort of issues around sufficient memory and disks. Few people are now using sort of RAID 5, RAID Z on the server where it's not appropriate, which is good. It was kind of one of those themes where if you had a performance problem, a ZFS performance problem, you could like look at nothing and say stop using RAID Z, and then go, what did you know? Which is most of the time that's what it was. That's kind of outgrown that now. The other issues we come across, ZFS, DMLC, contention, sizing. For ZFS, again, I've mentioned this, have a look for the spin mutex column in MPstat and lockstat. And then, I mean, it's sort of, now if say we take a T5, what's a high number of spin mutexes? Well, it kind of depends. 100 isn't much, 200 isn't much, 20,000 might be a lot, 8, who knows? But we really got to look at things like the hold time, also the time that locks are held, and to kind of work out if it's relevant or fire it off to us. And if you've collected that up front, things will move faster. One of the things I've a couple of last 3 years, and it seems to be getting worse, is kind of power saving issues on sort of Intel x86. So there were some pretty serious power saving bugs in terms of introducing latency bubbles pre sort of update 9. Those tend to be sorted out, but mostly around C state. You can turn the C state off. And if you're really worried about performance, that's what people are doing. But the M3 Intel M3 processor introduced this great thing called uncore frequency scaling, where it basically slow itself down, or slow the bits that weren't on the actual core, the off-core bits, the uncore, and slow it down. So things like interrupts, the device would interrupt and it would have to wake the uncore up and go, oh, right, now the little, oh, right, what's happening? Yes, okay, I'll deal with this interrupt. So that could introduce quite significant delays, and that was a BIOS setting. You set this uncore frequency scaling. And talking to some of the people who develop these machines, they see this being a trend that's going to get worse. There's going to be more and more power saving going into the Intel by default, and working out either as a code for the sort of data center class stuff, or turning them off is going to get more and more challenging. But it's going to be, I think this is going to be a theme that will continue to run on. So, we return to the iceberg of performance. And so hopefully that's been a random walk around little bits of the iceberg. So, I've got a couple of crusades. how do we as a vendor, Oracle, get better? And we're good already, but how do we get better at resolving 10 gig performance issues? As an engineering organisation, in terms of do we have diagnostic gaps, as a support organisation, it kind of comes down to this thing of better blame management. Didn't say that. Other things I'm interested in is large system post-mortem diagnosis. So when a system panics, creates a crash dump, and the crash dump itself is 10 terabytes. How do we start noodling our way through that? In some, it's not taking the same amount of time that deep thought took to come out with the answer of 42. Big system testing quality. That's really around, as systems get bigger and bigger, how do we find the edge cases that our customers who are psychopaths, I'm sure some of them here, managed to find. And I mean, it was the same when I worked for Cray years ago. The Met Office used to be, some of their workloads would expose issues that no other Cray customer. I mean, I think we had this biggest Cray there at the time, sort of 96, 97. And it was exposing issues that none of the spooks or nuke community had managed to expose because it was just a bigger machine. So there are algorithms that wouldn't scale. And I think it's how do we get, how do we take the learning from the current class of machine and then scale that up. And I'm going to go for a little run later this year. So one of the things is, 10-minute chat is always free. I'll put my mobile number on the presentation somewhere. If you have an issue, you don't know where to take it. If it's meant to go through support, I will tell you that. Don't be offended. It's always better to get things into process. But you have something out of process. I really am interested if you have 10 gig network performance issues, now or in the future, I'll come and see you. Buy me lunch, that's one of the things. So, hardware, software, engineer to work together. Right, now then. So, this is where you learn that I cannot type. So, I have, we're doing some work with the customer at the moment, and we've got this M9000. It's not very big. What's that? About 300 gig or so. It's about 200 CPUs. But that's the sort of machine that we had access to in the lab to reproduce problems and the particular sort of scale issues that we're trying to reproduce at the moment. So what I've done is I've managed to get this. I've just got using that well-known performance tool, a muck file. I'm just creating a file, moving it around on a share on a ZFS appliance. And what I've done here is I've selected, let's do it again. Let's do it from scratch, shall we? Get rid of that. So I'm going to add a statistic, and I'm going to use NFS4 operations, and I want to break them down by latency. There's a reason I'm doing this. So it goes away, and it starts, and this is very, very quick. Now this is on a lab. Neither machine is busy. It's one stream of I/O. How fast is this lab switch?
It's probably 10 gig if you're doing it direct to the Amber Road, or otherwise it's 1 gig every.
Yeah, and we're nowhere near that. Here we can see most of our I/O is really quick. So that's kind of fast, isn't it? Speed of light. But so most of them are down there. But that's not what I wanted to show. How many people read the sort of blurb? Because I give that blurb out, I don't know how long ago. I didn't really think about it. It doesn't relate to what I've said, but it included some of that Victor Meldrew. And I was sitting in an office in the US with a customer, and we were trying to work out why there were these high latency. And we were blaming the client because they'd spent a couple of weeks, and some really clever people from Oracle had spent a couple of weeks saying, no, this here says that the NFS operations on the client, from the server point of view, are really quick.